Now let's look at one more example with pi. Now this time we're going to calculate the sample statistics ourselves, unlike the previous problems where the sample statistics were given in the chapter problem. Okay, now we're going to revisit the same problem as the automobiles from sheet 1. Now conduct a hypothesis test and verify the claim that less than a third of the automobiles manufactured by the 5 countries have at least 30 miles per gallon as gas mileage. Okay, so at least 30 is the condition that makes a case success or not. So success is defined as MPG rating is at least 30 miles per gallon. So pi then is the population proportion that meets that condition. Now the hypothesis is, okay, 1/3. The value is 1/3, right? A third. So here one more point that I want to make is some students may have a tendency to type 0.3, which is really bad. Some of them may say 0.3333, which is all right, but we can do better than that. But some of them may even do just 0.3, which is really bad, because 0.3 is not 1/3. Okay, so you have to be as close to accurate as possible, and Excel allows us more accuracy, and that is you just do 1/3 like that. Then you get the most accurate value possible in Excel for a third. So you go 1/3 like that. Okay. Now, what kind of hypothesis is this? Is it a two-tailed hypothesis or a one-tailed hypothesis? Well, conduct a hypothesis test to verify the claim that less than a third, so less than a third is what we want to be able to say. So here this is less than is the alternative hypothesis, which means the null is greater than or equal to. So this is a one-tailed test, and let's assume an alpha 5%. So now the sample, okay, now we know we have MPG already defined as a name. So go to formula as a name manager to check that. So we do have MPG already defined. So sample size is simply count of MPG. That will give us the number of sample observations. The number of successes here, so we're going to do a count if. Remember, we did a count if for number of cylinders in chapter 8. So it was a particular number, so we just did comma 6. But now it is not a particular number. We want at least 30 for MPG. So you have to put that in quotation marks. At least is greater than or equal to, not simply greater than or equal to. Okay, so that's the condition. So close parenthesis, and that will count how many observations are there with 30 or more in the column. So P then is the sample proportion. Right, that sample proportion is that divided by that. Okay. Now S sub P is, you have to use the value of pi in the hypothesis, so square root of pi times 1 minus pi divided by n. Okay, now Z stat then is P minus pi divided by S sub P. Okay. All right, so now the Z table value, so this is a less than alternative hypothesis. So our Z critical value is on the left side, so it's a negative value. So norm dot S dot INV. Okay, now all we have to do is to give it the cumulative probability. So we want the cumulative probability. So if alpha is the tail area on the left side, that would be the cumulative probability. So we simply give the cumulative probability. So that will give a negative value. Okay. So conclusion is this negative value is greater than the critical value. It's closer to 0. So it's not farther away from the midpoint. So conclusion is not reject. So it's less, it has to be less than Z table value, but it is not. Okay, so that's why you do not reject. Now p value is, you do norm dot s dot dist. Okay, so the negative value, so that will give us the cumulative area, that's the tail area then. Cumulative area is the tail area, it's a one tail test, so this is our p value. This is norm dot s dot dist of the z stat. Okay, and since it's a negative, it's on the left hand side, so tail area is your cumulative area, so put cumulative, that will give us the p value, and that is 28.3%. So it's greater than the threshold of 5% that we have said. It's too high a risk for us to reject the null hypothesis. So p greater than 5%, do not reject, and then you interpret. So here once again we first say that we are not going to reject, and then say that if we rejected, so that's when your p value becomes applicable. So if we do reject, if we conclude otherwise, then the probability that the conclusion is wrong is 28.3%, and that's the reason why we are not going out on the limb.